We are waiting the other students. 1 minute. Okay, we can start. I can open my camera. Yes. Good. Last week we start with the introduction. I said you we have no midterm exam and final exam. I will give you project and homework. Actually, last week only 5 or 6 students sent me their homework. Others will be at a 0 after this time. 5 or 10% of your first grades will be 0. Okay. Thank you for sending students, homework submitted students. Who am I? Bir dakika. Courses falan, homeworks. Kim yolladı? Who sent me? Firstly, Amir Almakzub sent me. Amir, and then another. Also, one student sent me, but he or she didn't write his name. I don't know. So, unfortunately, his homework will be 0. Another student, Mariam, sent me. Also, Mariam sent me. Also, Abu Bekir Alasni sent me. Muhammed Al-Makbuli sent me. Also, another person sent me, but there is no name and surname. Also, it will be same another student. Okay, only 5 students have a grade. Others are 0. To PDF or email. I am waiting PDF name. If it has, yes, you have a grade. Which one? I didn't remember. Please check your email are available or no. No. Yani in my email there is no Adel. I checked, no. No, I check again. No, unfortunately Adel. Maybe you didn't write your name. Please check it your PDF. Okay. Send me again as soon as possible. I can check again. Okay. Okay. Well, in this course, we will focus, I said you, electromechanical energy conversion, control system, power electronics, and software, microcontroller integration of these 4 cores actually. We can say best example for electric drives application, electric vehicle. It is a very popular, In this course, in midterm or final project, I will give you electric vehicle design, for example. Why we can say combination of this course? Because third year you have microcontroller, power electronics, electromechanical energy conversion, and control system. Normally, electric motor consists of powertrain. Powertrain consists of power electronic circuit, converter circuit. Also, in some application, we need battery. After this course, you need to calculate some parameter for your electric drive system. How can you select an electric motor for your application? How can you calculate your torque requirement, your power requirement, your speed requirement? Okay. Generally, every week I will give you 1 hour. It will be online 1 hour course. This week we can start with the sizing of the some parameter. I have an example forklift vehicle. We will start with it. Next week homework. Every week I will give you homework. Don't forget it. After that we will combine them. It will be your near limit term project. We will add some parts. For example, last week homework, we will use it. Okay. Last week, if you developed an DC motor speed controller, we will use it. Don't worry about it. Every week, I will give you homework. We will use. Now, this week, we will start with the dynamic calculation of the vehicle. Okay. If you want to design an electric drive system, firstly, you need load or you need motion capable system. For example, I say to you electric vehicle. Another good example, wind turbine. Another good example, conveyor. Another good example, elevator. Another one, forklift, electric forklift, for example. These are conveyor, elevator, some servo machines. They are very popular examples. Okay, today I will show you a vehicle dynamic equation. Normally, in some courses, especially mechatronics students know that we have two vehicle dynamic model. One of them longitudinal, one of them lateral. Lateral actually advanced for this course. Generally, in the electric drive system, we must calculate longitudinal effective forces. Okay, sorry. Today, we will focus forklift. This paper is very good, sizing of lithium-ion battery. If you want to understand the electric drives, I will upload this paper. Please read it in detail. After that, you will see some part of electric drive system. Now, what is it? You can read it with together. Firstly, the researchers of this paper focus, they wanted to develop an hybrid electric forklift. Okay, like us. In this course, we try to develop an electric forklift together. Okay, this is just the first step of our design. Today, we will start with the longitudinal vehicle dynamic calculation. Why hybrid electric vehicle is important for us? Because we have some keywords. Okay, if we want to struggle with the classical greenhouse gas, etc., electric vehicle forklift and very good option. I know, but this is just 10 classical sentences. In this course, we need to know design steps. We are starting with some keywords: lithium-ion battery, supercapacitor, weight, volume, cost, hybrid electric vehicle, drive cycle, and forklift. Actually, if you learn all these keywords, probably you will be expert. Which keywords are important for us? Hybrid electric vehicle, drive cycle, and forklift. Lithium-ion battery, supercapacitor, weight and volume, another section of the another course. For example, power electronics. For example, some battery course. Why we can say hybrid energy storage system? Because they are using supercapacitor and the battery. Okay, we can say hybrid system. Also, in the next page, this is classical literature review. Okay, in your report, in your homeworks, I am waiting like this one reference literature review. For example, you can see like this one. What is the literature review? For example, they consist of powertrain system used for driving and lifting operations in indoor or outdoor environments. Forklifts can be classified according to their power source, petroleum gas, diesel, or electric. They at reference 869. Okay, they support their idea with these references. Okay, actually it's very generic knowledge. Forklifts can be classified according to their power source, LPG, diesel. I know this is very generic knowledge, but you need to add references like this one, 868 9. If you check 689, you will open this paper, you will check 689, how can they obtain this information. Okay, in your mind, I know LPG is very common usage, but you need to support it. Okay, this is important part of the discourse. Every knowledge, every project steps, every calculation must support with academic research paper. Okay, for example, especially if you add like and however is meaning that very important subject. If you say however, you need to support, obviously. However, for indoor applications and industry 4.0 requirements, zero emission is mandatory. If you say anywhere of your research or report mandatory, you must add a reference, because mandatory is probably depend on the standard, depend on the academical opinion, etc. They support using an 10 and 11th reference. Okay, what is it? Therefore, electric forklifts are widely used these past few years. If you say, therefore, electrical forklifts are widely used these past few years, this is knowledge. Maybe I know 50 years ago, everybody used electric forklift. Maybe you can say 10 years ago, everybody used electric forklift. We must support it. A few years is meaning that I checked the academic paper, I checked research paper, a researcher group from Germany, for example, they said hybrid electric forklifts are widely used last 10 years, for example. You must add reference. Okay. Also, this is introduction and this is a literature review section. You will add all homework, all paper, like part. Okay, this is critical. Yani end of the semester, I checked your grade. I will add a point, depend on your reference. Next part. Every drive section, every electric drive systems needs a cycle, driving cycle. What does it mean? First critical keyword, driving cycle. For example, maybe you can write WLTP. Okay. All vehicles in the world use and a drive cycle. For example, if you developed an electric vehicle or if you developed a commercial vehicle, we have some test standards, some lifetime calculation, etc. Some standards institute present a cycle, driving cycle. For example, this is a classical driving cycle. Time in x-axis, time, speed. For example, 1 kilometer hour. And then 1 again, 50. This is a road speed profile. If you want to design and motion controller or drive system, you must create a speed profile. In your midterm project or next week project, or a forklift, we can use this drive cycle, industrial forklift drive cycle, the Varian Dösche falan falan. This is probably German drive cycle, VDI-60 drive cycle is used. They add the references. It consists of a cycle repeated 45 times within 60 minutes with load of about 70 of the rated capacity. Yani, so it's meaning that your vehicle will be tested as a these sentences. Okay. Cycle repeated 45 times within the 60 minutes with a load of about 70%. This is very critical. Lots of students sent me only one constant speed. Okay. I, I am not waiting like this one. Only maximum performance limit is depend on your maximum reference velocity. For example, if you want a sport car or traditional car, your maximum speed is accepted as a 180 kilometer hour, for example. This is your maximum performance. However, in the industrial application or personal individual application, uh, every we cannot use every time constant speed. Our speed profile is changing every time on the road, sometimes 5 kilometer hours, sometimes 10, 11, etc. Every time interval, our drive system performance will be changed. It is very critical. Okay. In next week we will define our motion profile, but this week most important information is it. Also, your design in midterm project start at position A. The forklift holds the load. Don't forget it. Forklift holds the load. Okay, this is very important. A vehicle holds the load. What is the load? Load is some production mass, some passenger. For example, a car involve 5%, 4%. Okay. Second, forward travel from A to B, lift the load up to 2 meters. You will create a load. Load is here. L, distance L. A, first is forward travel from the A to B. Where is B? B here. A to B, I suppose that. Lower the load. Backward travel from the B to C again. Forward travel from C to D. Also lower the load and backward travel from D from A. End of the cycle. This is our cycle. Traveling distance, traveling aim, target, also some load condition. Okay. Now, in the next slide, you will see some forklift dynamics. You can use these dynamics. What does it mean? Drag coefficient, forklift front surface, air density, static rolling resistance coefficient, dynamic rolling resistance coefficient, forklift weight without battery and load, 70% of maximum load weight, gravity, angle of inclination, traveling speed, load lifting speed, load lowering speed. Actually, end of this course, we will build like this one. Okay, this is our reference. Yani, we neglect this part, we neglect this part, we will create only powertrain, motor, inverter, and battery. First, second homework, I will explain. Yes. To the next week, we will learn dynamics of equation. We have 7 equation here. First one, F aero. What does it mean? I said you we are using longitudinal forces in the vehicle dynamic calculation. This is aerodynamic force affect the car. Okay. Main formula 1 over 2 times rho. What is rho? Rho is air density. You can use air density from here. What is it? Rho air density. We can accept 1.25. Okay. Second formula, second parameter, S. What is S? We can check. S is forklift front surface. We can accept it 1.676. This is the frontal area of the forklift. You can imagine front view of the forklift. A length, width, AB, front area, A times B. Okay, this is your front surface. Wind affect this part of your vehicle. Okay. Also, another part, Cx. What is Cx? Cx is drag coefficient. We know this parameter. Actually, you can calculate. Also, we know the forklift speed, VEH. This is forklift speed. You can calculate your aerodynamic forces to your forklift. Okay, F aero is okay. Now F wheel. F wheel is affect wheel forces affect the wheel. Okay, total wheel. We have a 4 wheel in forklift. Total M FKT, M load, also C0, C1, etc. We can check it. MFKT here, forklift weight without battery and load. M load 70% of maximum load weight. We know this parameter. Also C0, C1. What is it? C0 dynamic rolling resistance coefficient, C1 static rolling resistance coefficient. We know this parameter. Now we can say we can calculate force affect the wheel. Second parameter. Okay. First one, second one. Now another one, Fg. What is Fg? Fg actually are classical actually mg sine alpha. Actually, firstly you calculate the total mass, gravity, and your slope angle. It's depend on your slope angle. Okay. Next one, FACC. FACC acceleration forces. We are using again total mass and then derivative of vehicle speed. Totally, we know total forces F aero plus F wheel plus FGX plus acceleration force. Now, for example, next week you will calculate it actually. Okay. You can see all parameters are clear. I will upload this paper. All parameters are clear. All student must calculate. Can calculate it F total. After that, in drive system, first thing we must calculate force. However, don't forget it. Force and power are different things. Okay. If you want to power, we must know force. This is a motion system. Don't forget it. We are using power. Maybe you can remember what's the unit of the torque? Newton meter. What does it mean? Newton is force, meter, or velocity. Displacement. Okay. Power unit, watt. Here we are using total forces times vehicle speed. It will give us vehicle power. This is very critical. If you want to design and drive system, we need to know power requirement, power demand, speed demand, and torque demand. Now I calculated the vehicle power demand. And in second scenario, to do now, I calculated like a classical vehicle. However, don't forget it's forklift. In forklift operation, we have lifting. If you want to calculate lifting performance, F lift, lifting force will be equal Fg plus F acceleration lift. Lifting acceleration, M load. M load is your load. Okay, don't forget. This is not a vehicle load. Yani product load times forklift speed, derivative of forklift speed. Also, another one, Fg. Fg, you know the mg cos alpha. This is depend on your slope. Finally, lift of power will be equal lift of force of lift times vehicle speed. This vehicle will be forklift. To the next week, I am waiting these calculations from you. And 2 weeks later, yani next week we can discuss power needs. After that, we can select motor and power electronics units, etc. Okay. Also, this next weeks we will continue this part. Now I will open another document. Wait me. This is first side. Now I will share an electric vehicle. Wait me. Yes, it's coming. Also, please check the OLearn website. Every time I will upload some documents. Okay, please check it. This is another example. This is electric vehicle design process. Same with the forklift, but some parameter will be changed. I said to you, every design steps start with the total friction, force, and power. Here, very light electric vehicles are available. For example, here are Opel Corsa. Its internal combustion engine power 44 kilowatts, empty mass with a motor 880 kilogram, frontal area 2.08 square meter, wheel friction coefficient 0.015, aerodynamic coefficient 0.36, wheel radius 0.28. Okay. In forklift, probably you need wheel radius. You can select from internet maybe. You need to select and forklift wheel. Why it's important? We need to calculate force and torque. It depends on relation to wheel radius. Okay. Yani F time wheel radius will be equal torque. Okay, torque and force are different things I said. 5 minutes ago in our table, it's not available. You can select from Google. If you can write the forklift wheel radius, you will see. Now, in electric vehicle, what's the operation condition? Calculation of the power of EV is done by considering optimum condition. Okay. For example, I accept Vx, vehicle speed, 130 km/h. my maximum theta slope of the road is taken as 5 degree. Okay. Another parameter I set for forklift, it is necessary for normal EV, rolling resistance. It is result of the tire rolling, don't forget it. If you have any tire, we need to calculate rolling resistance. Also, the total force that is needed for the vehicle traction calculated 1320 Newton at maximum speed 180 km/h. How can we calculate it? If you remember forklift paper, we have a four equation. One of them aerodynamic force, one of them friction force, one of them sloping road force, one of them acceleration. If you sum of them, you can calculate total force. For this vehicle, our force 1320 Newton. I accept my vehicle speed maximum because I must calculate maximum operating condition. My vehicle probably goes with 90 km/h, 60 km/h. However, I need to consider maximum speed. Okay, how I can calculate the torque as a 370 Newton meter? Because I know my vehicle speed, wheel speed. Wheel rotation speed is meaning that RPM. Vehicle speed, wheel speed. Wheel rotation speed is meaning that RPM, 1700 RPM. If you convert RPM to linear velocity, you can obtain Newton meter torque calculation. Now I know force, I know wheel radius, I know my vehicle speed. Is it correct? I think no. Or yes. How can I calculate it? Because my maximum speed 180. If you know your maximum speed, you can calculate your vehicle wheel speed. How? You can convert from linear velocity to RPM. Is it correct? Yes. You know the radius of the wheel, you know the linear velocity, you can calculate as a RPM. Okay. After that, if you know the RPM, if you know the torque value, you can calculate power. My power will be equal 70 kilowatt electric motor. Another criteria, gear ratio. How can we specify it? Normally, if you select an electric motor, we have rated speed. Also, we have vehicle speed. For example, your motor rated velocity, don't forget it, motor rated velocity, for example, 3000 RPM. Your vehicle velocity, 12,000 RPM. You need to add a gear in order to obtain the speed. It will be 4, for example, 4/1 gear ratio. This is first step of motion. You can multiply it for conveyor, for elevator, for wind turbine, etc. But next week we'll start with the forklift. Okay. Do you have any question to me? Everybody understand the homework? Also first step of project. No or yes? Adele, I checked your homework. You didn't write your names.
I wrote the name and student number in the email, not in the PDF.
No, it's not acceptable. I am not accept email. I am waiting in PDF topics.
I
Okay,
sent
two
the
names.
PDF topics
Yes.
through the email,
Yes.
and I wrote my name on the email so that you know it's my submission.
Okay. Please write. Send me again. Okay. Now.
I'll write my
Listen.
name in the PDF. Is that what you're
Okay.
saying?
Yes.
Okay, I'll fix it.
Okay. Okay. If you have questions, I can reply. You understand homework now. Uh, you can start your homework as soon as possible. Today is enough, I think. We can continue next week. Every week 1 hour. Okay. Online courses will be 1 hour because we will focus project. Also, yes. Kim o? Who? Do you have any question? I hear some voice. Okay. If you have a question, if you have any problem in your homeworks, in your projects, please visit me. Okay. I'm waiting every time. To the next week, I am waiting a dynamic model of forklift. Okay. I will upload brief of your homework today or tomorrow maximum. Also, please check the all learn. I say again, we have no midterm exam and final exam. Thank you for your attendance today. We will continue next week with the electric motor selection criteria. Also, we can discuss your homeworks together. Please send me end of the Wednesday. After that, I will open some of them. We can discuss together. If you have a wrong, we will revise it. Thank you. See you next week. I am waiting your very well homeworks. Okay. Bye bye.